Here's example 5 of using reference angles to evaluate trig functions. So in the first 4 examples, we used angles that we talked about in separate videos where we already found the reference angle. So let's do one where we have to go through the entire process from the beginning. So 585 degrees, that's an angle we haven't looked at yet. So let's go ahead and start with this. So remember, the first thing to do is find the reference angle. Okay, so that's what we're going to do first. We're going to find the reference angle for 585 degrees. Okay, so first thing we ask ourselves is, okay, well, it's in degrees, so is it between 0 degrees and 360 degrees? No, right? It's clearly larger than 360 degrees. Okay, so then what we have here is 585 degrees is greater than 360 degrees. Okay, so now remember, what we do in this case is find a coterminal angle, or find the coterminal angle between 0 degrees and 360 degrees. Now what we have to do is take 585 degrees and subtract 360 degrees as often as necessary. As it turns out, it's only going to be once. Okay. So 585 degrees minus 360 is going to give us, minus 360 degrees is 225 degrees. Okay. So 225 degrees, that is between 0 degrees and 360 degrees. So now, since 225 degrees and 585 degrees, they're coterminal. So first of all, what we can say, just like in example 4, we can say, okay, well, since they're coterminal, their trig functions have the same values. Okay, so we can say that. Okay, so actually what I want to do now is just totally forget about 585 degrees and let's just focus on 225 now, okay? So we'll just focus on 225 degrees because these are exactly the same, because 585 degrees, 225 degrees, they're coterminal, so their trig functions are the same evaluated at each of these, okay? So cosine of one is the same as cosine of the other, and same for the other 5 trig functions. So we'll just forget about 585 degrees now, just focus on this guy. Okay, so now since we did that, now we're still looking for the reference angle, right? We're not done yet, we want to find the reference angle. Okay, so all we've done so far is use a periodic property, which technically we didn't actually really have to do, but why not? Okay, why not? So 225 degrees, that's the angle we're dealing with now. Okay, alright, so let's go ahead and draw. What we want to do now is draw this guy. So since now we have an angle between 0 degrees and 360 degrees, we want to draw that angle. 225 degrees, where is that? That is a special angle on the unit circle. If you've been following the videos, we haven't really talked about those angles in terms of degrees, but hopefully you do remember how to convert between degrees and radians. So take degrees, multiply by pi over 180 to get radians. Okay, and then if you do that, you might recognize which special angle that is. But let's say we don't. Let's not go through that route. Let's just think of it like this. Okay, 90 degrees would put me up here. 180 degrees would put me over here. 270 degrees would put me down here. Oh hey, 180 degrees, 270 degrees, 225 degrees is between those guys, okay? So 180 degrees is less than 225 degrees, which is less than 270 degrees, okay? So 225 degrees is between both these guys here, so let's go ahead and draw that angle there. So 180 degrees is over here, remember 270 degrees is down here, 225 degrees is between them, so that would be somewhere in quadrant 3, so we'll just draw it like that, okay? So here is 225 degrees. Okay. Now since 225 degrees puts us in quadrant 3, how do we get the reference angle if we're in the third quadrant? So remember, to get the reference angle from the third quadrant, as long as you're between 0 degrees and 360 degrees, which we are now, take the angle that you have, 225 degrees, subtract off pi radians, or in this case we're talking about degrees, so subtract off 180 degrees to get rid of this piece, so then all you have left is this. Okay. So maybe I should have written it vertical. But anyway, 225 degrees minus 180 degrees. So if you do that, you're going to get 45 degrees. Okay? So the reference angle here, this is 45 degrees. Okay? And that's great. 45 degrees, that's a nice special angle on the unit circle, right? So remember, 45 degrees, that's the same thing as pi over 4 radians, right? Pi over 4 radians. Okay? So 45 degrees is pi over 4 radians. Anyway, how does that help us though? So now let's come back up here. We talked about this in more detail in example 1. So if alpha is the reference angle for a given angle theta, then the cosine of theta and the cosine of alpha are the same, except there might be a minus sign here, and the sign, SIGN sign, depends on the quadrant of theta. Okay? Well, now we come over here and we say, okay, let's erase this. 225 degrees is in quadrant 3. Okay, 225 degrees is in quadrant 3. So what can we say about the cosine and the sine? So cosine of 225 degrees. Now if we're in quadrant 3, remember cosine corresponds to the x-coordinate on the unit circle. And to the left of the y-axis, x-coordinates are negative. So in quadrant 3, cosine is negative. How about the sine? Well, remember sine corresponds to y-coordinates on the unit circle. And if you're in quadrant 3, you're below the x-axis where the y-coordinates are negative. Therefore, the sine of 225 degrees is negative. Okay? Now again, we're talking about 225 degrees, but remember 225 degrees and 585 degrees, they're coterminal. So these trig functions, this one equals this one equals this one. And again, we just could forget about this one completely. Okay? But also, since we found out 45 degrees is the reference angle for 225 degrees, 45 degrees is also the reference angle for 585 degrees. Because remember, coterminal angles have the same reference angle because reference angles are defined in terms of terminal sides. Okay? So remember, a reference angle is the acute angle between the x-axis and the terminal side of the given angle. Well, if two angles are coterminal, they have the same terminal side, so they have to have the same reference angle. Anyway, we talked about that in earlier videos also. So anyway, continuing with this, now we come up here and now we're going to apply this to this over here. Okay, so now what we can say is, okay, cosine of 225 degrees, that is the same thing as the, I'll have to get rid of this again. That is the same thing as the cosine at the reference angle. Okay, the reference angle is 45 degrees. Okay, but remember there might be a minus sign in front. How do we know? Well, we found out here the cosine is negative. So because of this, because the cosine is negative here, we have to include this minus sign now. Okay, we have to include that minus sign. So we have to slap on a minus sign in front of this. Okay, and remember 45 degrees, that's the same thing as pi over 4 radians. So if you don't have that one memorized, it might be a good idea to have that one memorized because it's in the first quadrant. But remember, pi over 4 radians, the cosine is root 2 over 2. Okay. So this, since we have the minus sign in front, then our answer is negative root 2 over 2. Okay. And likewise with the sine of 225 degrees, that's the same as the sine at the reference angle. I'm going to have to erase this. It's the same as the sine at the reference angle, but remember, we might have a minus sign in front. How do we know? Well, we go down here. Okay, we found out earlier the sine of 225 degrees is less than 0. It's negative. Therefore, we have to include this minus sign. Okay, because remember, this is true for all 6 trig functions, not just for cosine. Okay, we wrote it for cosine, but it's true for all 6 of them. So anyway, we have to include this minus sign because we found out that the sine of 225 degrees is negative because 225 degrees is in quadrant 3. Okay, so we have to say negative sine of 45 degrees, which again, 45 degrees is pi over 4. The sine is the y-coordinate, root 2 over 2. So this answer is also negative root 2 over 2. Okay. Okay, so that's example 5 of using reference angles to evaluate trig functions. So negative root 2 over 2 and negative root 2 over 2 for both of these guys.